Hello, I am Dr. Sharvani Mukherjee. Welcome to my YouTube channel Let's Do Maths. Today we are going to discuss open ball, closed ball. Now we already discussed what is an open ball in my another video. Just recall the definition. The open ball, usually denoted by B, X, R, it is the set of all those Y in capital X such that the distance D of X and Y is less than R. Note that here obviously the metric space is XD. Now, what is the closed ball? Usually closed ball is denoted by within third bracket X, R instead of first bracket. And this is nothing but all those Y in the metric space capital X such that distance of X and Y less or equal to, here equality considered, less than equal to R. This is our closed ball. So let us consider an example. We consider the metric space RD. Here R is the set of real numbers and D is defined as dxy equal to minimum of 1 and mod of x minus y. Then we have to find the closed ball B2 Now what is the meaning of this? This means this is all those x in R for which minimum of 1 and mod of x minus 2 is the center. This is distance is less than equal to half. So minimum is less than equal to half. So minimum always gives from this part. Therefore we can write x, all those x in R such that mod of x minus 2 less than equal to half. And after simplifying you get all those x in R such that 2 minus half less than equal to x less than equal to 2 plus half, and therefore it is 3 by 2 less than equal to x less than equal to 5 by 2. So B2 half means all those x lies within the closed interval 3 by 2, 5 by 2. This is the closed interval. If you consider the open interval, then you get the open ball B2 half. In real analysis, you know a point x belongs to capital A, which is a subset of the real number set, is said to be an interior point of F if there exists a neighborhood of x. We can say that the open interval x minus epsilon, x plus epsilon, which lies entirely within capital A. Now the parallel notion of interior point in the metric space is the neighborhood of x is replaced by an open ball. All other things remains unchanged. So, what is the definition? What is the formal definition of an interior point? Let us write. Let xd be a metric space and capital A subset of x. A point x belongs to capital A is said to be an interior point of capital A if there exists an open ball BXR such that the open ball lies entirely within capital A. Now, note that the point should belongs to capital A for the interior point, and there exists an open ball means there exists at least one open ball. Okay, if we get an open ball which lies entirely within capital A, then we can say that X is an interior point of capital A. Now, every point of a set may or may not be an interior point. If every point of a set is an interior point of that set, then we say that the set is an open set. So, this is the formal definition. This is same as the definition of an open set in real analysis you already studied. Another thing, obviously, if we collect all interior points of a set, then this set is a subset of the given set. That is, the set of all interior points of the set, say capital A, is a subset of capital A. This set is known as interior of A and denoted by A naught. Obviously, from our discussion, we realize that A naught is a subset of capital A. When capital A becomes an open set, then we get the equality. So, bye for today. Please like, share and subscribe my YouTube channel. Thank you.